if I put them as a column vector, what this matrix multiplication really mean? I mean, we know previously already is this is x1, x2, xn. It's basically like x1 times e1 plus x2 times e2 plus overall plus xn times en, right? Equal to this b, right? Right? Okay, I mean, we know about this long time ago, right? I think like probably chapter 1 or chapter 2, I forgot, like probably chapter 2, we first discussed the matrix. Okay, so I told you there are many different ways to understand this matrix multiplication. So basically, like you have this solution x. Only when this vector b is in the column space, is in the space spanned by these column vectors, right? Because if you write it in this manner, you fully understand. In order for these xi's to have a solution, b must be somehow like a linear span by these bi's, right? By these column vectors, right? Okay, if not, then you don't have a solution. You don't have a solution. At least you don't have an exact solution, right? You don't have an exact solution. Okay? So if B is not in column space of A, the system AX equal to B it has no solution. Okay, that's why we say that. Okay. But okay. It will still be meaningful if you could find an x such that AX minus B, okay, this norm is minimal. It is still meaningful to find such thing. Okay, we know this AX equal to B is, this because B is not spanned by the columns vectors. I mean, there's no solution. But if we can find something that is very close to B, then, well, it's it's still useful. Actually, it is very, very, very useful. I mean, one thing I can tell you is that, like, 你知道那个有个数学家叫高斯吧？高斯 ，OK， I mean, Gauss is so famous. Like, we even have a distribution called Gaussian distribution, right? 其实就是什么 normal distribution， 大概是所有的分布里面，就是机域分布里面用的最广的一个，叫 normal distribution。那另外一个名称叫 Gaussian distribution。那 Gaussian distribution 就是 named after Gauss。Okay, so Gauss is 如果你说历史上有个我们讲5个最有名的数学家，高斯应该算其中一个。OK， 那事实上高斯在一开始出来的时候，他不是大家认得他的时候，大家不是认得他是数学家，大家认得他是认为他是天文学家。为什么？因为那时候有一个天体，那个大家要观测那个天体啊，但是那个天体观测，过了就是观到某个地方就看不见了，是不是 ？This because they observe this star, okay, it's a new star, but they try to derive the orbit, the projection, the track. They try to track this star, but because白天的时候，白天看不见，对不对？那个你 explore 你白天看不见，对，when there's a sunlight, you cannot see like star very clearly. So they lost the track of that star. Okay, but after a while they are able to track it again. Okay, so they try to track this star, and but it's just like they only get like intermittent like a data set. 就是他们拿到的是这个断断续续的资料集but they want to derive the whole like movement pattern. They want to derive the whole movement pattern. Okay, so they just 就像那个现在不是那个就是都会有一个就是你去看那个 Kaggle 对不对 ？Kaggle 不是就公开资料集让大家去试嘛，对不对？那有点像这样，就是那时候就是那个天文学家说，我有这个东西，有这个星星哦，就大家来预测一下，看这星星下面会在哪边出现。就是一堆天文学家就去估嘛，结果后来估出来，就是有点像就在 Kaggle 上那个资料集，那高斯估的是最准的，所以他就开始变得非常有名，大家都会他是一个很好的天文学家。那后来他就是因为这样才变有名。后面当然因为他数学的贡献嘛，后来大家才认可他是一个 mathematician。他开始的时候大家认为他是一个天文学家。那为什么会讲到这个故事？Why do I need to talk about this story? Because the way Gauss estimate that the trajectory of the star is to use this method. 他就是用这个，因为你在估计那个 trajectory 的时候，它一定会有 noise， 对不对？对不对？他在估那个 trajectory 的时候，你一定避免不了，一定会有 noise。那事实上呢，就是他那时候就用线性去估了，但是他线性估一定会有 noise， 那个 noise 怎么办？他知道说那个 noise 没有办法那个完全抹掉，这所有的考虑都进去也是没有办法，还是会有一些 noise。那怎么办？所以他们必须要找最接近的值。Gauss know that he needs to find the closest solution to this system equation. So he used this method. Okay, this is the method actually Gauss used to derive the trajectory of that star. Okay, which made him famous. Okay. So this is like a very interesting story. Okay. So how do we do it? So this actually has something to do with the projection. So because we know that this column vectors, column space is spanned by these column vectors, and this is obviously subspace. Right? This is obviously a subspace, right? So if you want to minimize this distance, the easiest choice would be to make AX the projection of B onto this column space. Okay? Because we know this one, right? We already know, okay, in terms of the distance, okay, the projection of B onto S, okay, B is closest to this place than to any other vector in this subspace. So it's we may as well just make the AX the projection of B onto the column space. Okay. So the minimum of ax minus b is given as ax equal to projection b onto s. So assume ax prime. We don't use x. We don't use x here because we don't have a solution for x. Okay, you have to keep in mind this is not the exact solution. Okay, we are not really solving the x equal to b. This is the system linear equation because there is no such solution out there. Okay, so ax prime, okay, equal to projection b onto s. This one has solution. Okay, because we know this projection will be a vector in the column space because this s is the column space. Okay, so then ax prime minus b will be projection b onto s. Okay, minus b. Okay, this one, okay, is orthogonal to s. Okay, it's orthogonal to s. Okay, and so because it is orthogonal to s, so a transpose dot this one will be 0, right? Because when you do transpose, I mean you make each column as a row, right? 你把那个列是列变成行的，对不对？对，那你这样乘的话，是不是这样变？那原来那个一column乘到这里面的一个column，对不对？那这样子的话，就一定是那个，因为它 inner product， 这就是 inner product， 那都会给力，对不对？那也就是说 ，OK，that is to say， OK，you know try to expand it。So ATAX prime equal to ATB. So then, okay, because no A is given, so AT obviously we know AT. Okay, we obviously know B, right? So ATA, ATB, we know this. The only thing we don't know is X prime, right? And we know this has solution. So this x prime, we can derive this x prime. Okay, we can derive this x prime. So once we get this x prime, okay, the ax prime will be our projection of b onto s. And the distance will be the ax minus b, the norm of that. Okay, so this is how we solve this problem. This is called normal equation. This equation is called normal equation of the least square problem ax equal to b. We call this as a least square problem. 这就是那个叫什么？那个就你如果给太多的那个点，或者说你的那个解没办法经过所有的那个，那你要找一个最小的那个。就我们中文叫最小平方法。为什么是平方？因为我们在 minimize 那个 norm， 那个 norm 会有跟平方相关。OK。好。So once you understand that, okay, we can take a look at some example. For example, this is like, A is this one, B is this one, okay. You can verify that there's no possible solution for AX equal to B. You can give it a try. I don't have time to do that, but you can give it a shot. Okay. So now, so what we need to do is we need to solve the normal equation. What is normal equation? So we use the ATA x prime equal to AT times P you solve this one. Okay, and by the way, if previously, if you remember previously, I call that matrix A as n times n, right? It may not be squared. It may not be squared, but now ATA must be a square, right? ATA it must be a square. So for example, this A is 3 by 2. But if you do this ATA, become like 2 by 3 times 3 by 2. So it becomes like 2 by 2. So ATB, okay, same thing, this one times B, so you get a 6, 2. Okay. So the normal equation becomes ATA times this x prime equal to ATB. So you try to solve this, the solution will be this one. I will handle with this because I think that for professors to do this calculation, I think you guys can do better than me. Okay, you have这个没有新鲜的肝嘛，对，所以你们的那个计算的会比我快一点，说不定也比我准确，对。Okay, but you get an idea. Conceptually, this is how it works. Okay, 所以我们有这个。然后呢 this is x prime. Okay, this is supposed to be x prime. And then our ax prime is this one. It is a projection of B onto the column space of A. So then, okay, if you want the shortest the distance, okay. If you want the solution, you want